when it comes to variable, it can be categorized based on two criteria. So one is continuous variable, the other one is discrete variable. So here the continuous variables are usually obtained by the measurement instead of the countable numbers. Two types of class intervals that can be prepared. So one is inclusive form of class intervals, the next one is exclusive form of class interval. Hello everyone, I am Dr. Nikhilavati S, Faculty of Commerce, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. I welcome you all for the sessions on the subject Economics for first PUC, and we are in the fourth chapter of Part A, that is Statistics for Economics, and we were discussing about the organization of data. So here in this chapter, in the last session, we have also discussed how to organize the data, what is organizing data is all about, what is raw data, and what are the various types of classification in which the data can be arranged. And in this session, we are going to learn what are the types of variables. One is continuous and the other one is discrete variables. And we'll be learning about how to do a frequency distribution, tally marking, as well as bivariate frequency distribution. So moving forward, first let us learn about variables. So what are variables is all about. In the previous session, we also discussed like what is a variable. Variable is a feature or any character or any factor based on which the data is collected. So here when it comes to variable, it can be categorized based on two criteria. So one is continuous variable, the other one is discrete variable. So first let us learn like what is a variable. So in statistics, a variable is any characteristics or a number or quantity that can be measured or counted. So for example, height. So I may collect the information about the height of the 50 students in a class, or weight or age. It can be measured in terms of numbers. It can be marks or number of children or income, etc. So here generally variables are in two types. One is continuous variable, the other one is discrete variable. So let us learn what is continuous variable is all about. So when we say continuous variables, in a variable or information, so these are the variables that can take any value within a given range. That means the values are not countable but measurable, and they can take fractions and decimals. Here it is called as continuous. That means a number, it will not jump from one number to other. Say for example, it will not jump from 3 and the next number will be 4. Or it can also take some of fractions and decimals like either 3.1 or 3.5, it can be 3.9, etc. So here the continuous variables are usually obtained by the measurement instead of the countable numbers. For examples, so these are the examples of continuous variable. Say height of the students. So we can say either it can be 150.2 centimeter or 160.5 centimeter, 172.8 centimeter. So it can't be always 150, 151, 153 like that. It can be in points also. So next, when we take the example of weight of a person, again weight can be 52.4 or 68.75 or 52.5, etc. When we take the example of temperature also, the temperature can be 24.5 degrees Celsius or 30.2 degrees Celsius. So here a time taken to run a race, it can be 12.34 seconds like that. So these are the examples for continuous variables. So then let us see what are discrete variables. So here discrete variables, these are the variables that can take only specific or distinct value. That means it cannot be, the numbers cannot be in continuous format, or it can't be measured in terms of decimals and fractions. So it takes a specific or distinct values. Like either it can be not 3.5, rather it will be either 3 or 4. So for example, if we take the number of students in class, I can say 30 students. So I cannot say 29.5 students in my class. So if I take the example of books also, so we'll come to the example later. So here the values are countable and not measurable. So we can count either it is 4 or 5 or 6 like that. And they are usually whole numbers, not fractions or decimals, and discrete variables are usually obtained by counting. So for example, we have number of children in a family. Either it is 0, 1, 2, 3. It can't be 2.5 children, 1.5 children like that. So next, number of cars a family owns. So it can be either 1, 2 or 3. So again, it can't be 1.5 cars, etc. So next, number of students in a class, either 35, 36, 37 like that. Number of goals scored in a match can be 0, 1, 2, 3, 4 like that. So this was all about variables, continuous and discrete variables. Moving forward. So what is a frequency distribution? So let us learn how to do a frequency distribution. So first of all, here a frequency means the number of times. So how many times a certain activity is done, or how many times a student or often he can perform, or what are the number of marks that have been obtained between 30 to 40 like that. So it counts how many times basically. So here how to prepare a frequency distribution. See, while preparing a frequency distribution, the following 5 questions need to be addressed. First, we should be able to understand, should we have equal or unequal sized class interval? That means for preparing the frequency distribution, we need to decide what is the class interval. So then, either if it is a class interval like 0 to 10, 10 to 20 like that, then whether this class interval should be equal or unequal. Next, how many classes should we have? So in the frequency distribution table, say for example, if the marks, a certain exam is done for 40 marks. So then how many class we should have? That means it is depends on the size of the each class. So if we take the size of the class as 5, so we can divide it as 0 to 5, 5 to 10, 10 to 15 like that. So if we take the class difference as 10, then it will be 0 to 10, 10 to 20, 20 to 30 like that. So here what should be the size of each class? Then how should we determine the class limits, as well as how should we get the frequency for each class? So to make a frequency distribution table, we have to learn what is class interval, what is the size of the class, what is class is all about, and what are class limits. So let us learn these through an example. So here in conducting or dividing, when we prepare the class interval, then comes 2 types of class intervals that can be prepared. So one is inclusive form of class intervals. The next one is exclusive form of class interval. So in inclusive form of class interval, say for example, both the numbers in a certain class, okay, say for example 0 to 10, 11 to 20, 21 to 30, 31 to 40 is a class year. So here in these class interval, both the numbers in a class, like this is the lower limit of the class, 0 is the lower limit of the class, 10 is the upper limit of the class. So here if we take the example, 11 is the lower limit and 20 is the upper limit. So always on the right side it will be upper class limit, then this side will be lower class limit. So here between the lower class and upper class, if both the numbers are included in the same class, say for example, a student who has scored 0 and a student who has scored 10. So both are counted in this particular class only. And one more example, if a student has scored marks 11 and one more has scored 20. So both 11 and 20, both the class limits of the same class are included in the frequency calculation, then it can be called as inclusive. But in exclusive form of class interval, as it is like this, where it is 0 to 10, 10 to 20, 20 to 30, 30 to 40. So here, as you can see, 10 is both in this class also and here also. So in any of the class, you can exclude 10. So the student who has scored 10, you might record it in this class, and from 10.1 or 10.5, you can record in this class. So in this particular class, you are leaving that 10. So that is, you are excluding it. So that is exclusive form of class interval. Now let us see an example for frequency distribution. See, this is an example for frequency distribution, and this table is called as a frequency distribution table. And this table presents us the lower class limit, upper class limit and class mark. So first let us learn what is class is all about. So class is the divisions we make, okay, based on the equal interval or unequal interval. We divide the classes, that is 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that. So this column is called as a class. And next is frequency. Frequency here refers to the number of times one particular thing has occurred. Say if we think this is an example of marks obtained in a subject called mathematics from first PUC students, then there is one student who has scored from 0 to 10. There are 8 students who have scored from 10 to 20. There are 6 students who have scored from 20 to 30. There are 7 students who have scored from 30 to 40, like that. So by seeing this frequency, we can make out the majority have scored like 23. The highest number of students have scored marks from 50 to 60, and the majority have scored more than 40, like that. It indicates the number of times a particular variable has occurred. Next is lower class limit. Lower class limit is nothing but, see, this is a class, and here the lowest number here can be called as the lower class limit. So in this way, so all these left hand side numbers can be called as lower class limits. So in this particular class, the lower class limit is 0, and from 10 to 20 it is 10, next it is 20, next from 30 to 40 it is 30, like that. Then next column is all about what is upper class limit. Upper class limit is nothing but the highest number in each class. So the highest number is 20, here it is 30, 40, 50, like that. So the same thing is recorded here. In this class, the highest or upper class limit is 10, 20, 30, 40, 50, etc. Next we have is class mark. Class mark is also called as midpoint. So class mark here is the midpoint of the class interval. So here, how to calculate the midpoint? Lower class limit plus upper class limit divided by 2 can be the midpoint. So here, what is the lower class limit? 0. 0 plus 10 divided by 2 is 5. So here 10 plus 20 divided by 2 is 15. So like that, class mark is nothing but the midpoint of a particular class. So this is a frequency distribution table. Moving forward, let us learn what is tally marking. So if we take the same example of this frequency distribution, for this only if you are going to prepare a tally marking. So how to do a tally marking? So it is very similar to the frequency distribution table. We will write the class. Class is, as we have divided in the previous frequency distribution also, same class if we take, it is from 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that. So here the next column is observations. Observations means how many students have scored and what are those marks are. Okay, so previous frequency distribution table, there is one student who has scored from 0 to 10. So there are 8 students who have scored 10 to 20. The same thing here in tally marking, we are going to record the actual numbers or the marks that have scored between 0 to 10 and 10 to 20, like that. So here one has scored 0. So here we are going to write the actual marks. These are the observations. So here from 10 to 20, there are marks like 10, 14, 17, 12, 14, 12, 14, 14, like that. So here we are going to record what are those marks are. So in front of the class. And here the third column is tally marking. Say for one number or one frequency, we are going to tally mark like this as 1 mark. So here the frequency is 1. Like how many I have scored? From 0 to 10, it is only one student who has scored 0. So it is 1. And the class mark is 5. So for the next column from 10 to 20, there are 8 students, 8 marks which come under 10 to 20, and that is marked as 1, 2, 3, 4, and the fifth one is diagonal. And next 1, 2, 3. 8 tally marks and frequency is 8 and the midpoint is like 10 to 20, 10 plus 20 divided by 2, the midpoint is 15. Next 20 to 30, we have 6 marks which come under 20 to 30 and there are 6 students. So 1, 2, 3, 4, 5, 6. So 6 frequency is 6 and class mark is 25. That is 20 plus 30 divided by 2. So same thing continues, like in 30 to 40, there is marks like 30, 37, 34, 39, 32, 30, 35, like that. So here the tally marking is there are 7 students or 7 marks which come under 30 to 40. So for 7, like 1, 2, 3, 4, 5, 6, then and 7 and frequency is 7. So the midpoint is 35. It follows like this. Let us know what is loss of information. See, we all have learned, like while organizing the data, we actually transfer the data, like from the data which we have collected, we are going to transfer the data into a particular frequency distribution table or tally marking. Say if we take the example of frequency distribution, so there we have written the number of students who have scored from 10 to 20 is 8. So we'll only write 8 in frequency column. We'll not come to know like what are those marks, who have scored it, everything. But while collecting the information, we would have collected the names of the students, marks, etc. But when it comes to frequency distribution table, we are only writing how many have scored. So in that, the exact and the actual details regarding that frequency is lost. So that is loss of information. That means when we convert raw data into frequency array, some details are lost. Then in raw data, we know which students scored which marks, but in the frequency array, only we'll know how many students got a certain mark and not who got it. For example, in a raw data, we can say student A or C and D and H scored 25 marks. But in frequency array, we only know 3 students scored from, 3 students scored 25 marks, but we don't know which one has got it. So that is loss of information. Then frequency array. So what is frequency array? Frequency array is nothing but it's a simple table that we have prepared for, especially if it is prepared for the distinct value. That means when the variables are discrete variables and the table we prepare for showing the number of marks or a particular variable or a factor, it can be called as frequency array. And moving forward, let us learn what is bivariate frequency distribution. So here for variables, like we have taken the example of marks scored by students and we have done a frequency distribution table. So here it is bivariate. Bivariate means containing 2 variables. So if it is multivariate, it is more than 2 variables. It is univariate, it is called as 1 variable. So here bivariate frequency distribution is all about how to prepare a frequency distribution when there are two variables. So the first one is, say for example, this table shows bivariate frequency distribution of sales, that is in lakhs, and advertisement expenditure in thousands of 20 firms. So this information is regarding 20 firms, and it is showing the one side it is showing the sales in lakhs, and in other side it is showing the advertisement expenditure. That means there are two variables here. One is sales of that 20 firms and the other one is advertisement expenditure of those 20 firms. So there are two variables. So how to do a frequency distribution table for two variables? So we are going to give this column heading for one variable and this row heading for another variable. So here in this table, the sales of 20 companies are recorded like this, where it is from 115 to 125, 125 to 135. So this row represents the sales and this column is representing advertisement expenditure. So now let us see what it is indicating. That means there are, out of 20 firms, there are two firms. There are two firms whose sales are from ranging from 115 lakhs to 125 lakhs. They are spending advertisement expenditure of 62 to 64,000. Then there is one firm whose sales is from 115 lakhs to 125 lakhs. They are spending advertisement expenditure from 64,000 to 66,000, like that. So next, there is one firm whose sales is from 115 lakhs to 125 lakhs and their advertisement expenditure is from 66 to 68 lakh. So we can conclude that there are 4 firms out of 20 whose expenditure is from 62 to 68, and they are, this annual sales rate is from 115 lakhs to 125 lakhs. Same thing here also, there is one firm whose sales is from 125 lakhs to 135 lakhs and advertisement expenditure from 62 to 64,000. So like this. So if we take the example of this, we can say there are 3 firms who are, whose sales is from 135 lakhs to 145 lakhs and who are spending 64 to 66,000 for advertising. So in a bivariate frequency distribution means 2 variables are considered and the number of frequencies are entered like this in a table. So this is bivariate frequency distribution. So this was all regarding what are variables, what is bivariate frequency distribution and tally marking. So hope you all have understood. Thank you.